Hello students. There is a beautiful puzzle in chemistry, especially when it comes to counting of bonds. If someone asks how many carbon-carbon sigma bonds are there in a diamond which weighs 12 gram, right? And you won't believe that most of the students do not get it right for the first time. Why? Because they count in a different way. Let's draw a carbon and let's see how many bonds does it make. So we know that carbon is a tetravalent species, right? So each carbon in a diamond has this kind of thing, which you can easily visualize. So you can see there are 4 bonds in one carbon structure, right? And you know that one 12 gram diamond would contain surely 1 mole carbon atoms, right? That means how many carbon atoms? You know that Avogadro number carbon atoms. Now, if students are very simplistic in their thinking, then they will arrive at this logic. That means there are 4 NaCC bonds. But that is not exactly the correct answer. Why? Because in diamond, there is a network of carbon atoms. Carbons are connected with each other through a network. So, you know, when you count bonds of one carbon, that means you are not taking it in isolation. What I mean is that each bond in this structure is shared between 2 carbons, right? It is a shared bond, right? So when you say count this bond, you count this bond with this carbon, then you have a chance that you may count this bond with this carbon also. I mean, this bond is counted twice if you just do 4 times Na. So what's the best answer here? You have to divide everything by 2. So finally, the correct answer is there are 2 NaCC bonds. So now you make it right. So remember that whenever there is a closed network of particles in any structure like this one diamond, then bonds has to be counted with proper logic because each bond is shared between 2 carbons. So you have to divide by a factor of 2 if you are directly using the number of valency for counting of the number of bonds. So 12 gram diamond does not contain 4 NaCC bonds. It contains 2 times Avogadro number of CC bonds. That's amazing.